Okay, here I'm just going to do a few examples of the Unit 6 Day 2 homework, so that's over partial fractions. Keep in mind that this homework assignment is not exclusively partial fractions. For example, number 2 is using U substitution, and number 5, you should be using integration by parts, but the others are partial fractions. So I don't know if yours is quite as blurry as mine. Hopefully you've got it in front of you, but I've got the integration of 1 over x squared minus 6x plus 8 dx. So one of the clues that you want to use partial fractions is that this denominator is something that you can factor. It kind of has that rational function look to it. So the first thing you want to do is rewrite an equivalent integration, and we're going to say that's equivalent to the integration of 1 over, and all I'm going to do is factor that. So that factors into x minus 4 and x minus 2. Let me see if I could change the width of this pen. Okay, so once you kind of decide you're going to factor it, our whole goal is to kind of say, well, I don't know how to integrate that, but I do know that that would be equal to the integration of sum a over the first fraction plus some b value over the second factor. I don't know, I think I said fraction before. I meant to say factor. And that would, of course, be with respect to x. So you're going to kind of use an algebra 2 technique here, where if you say if the integral of one thing equals the integral of another thing, those two things have to be equal. So you're going to set the original one that's factored equal to this new thing that we've kind of created. So we're going to say, all right, well, if this is the case, then I want to use an algebra 2 technique that says I can get a common denominator if I'm trying to add fractions. So you'd say, well, this has this x plus 4, this side needs, x minus 4. So this side needs an x minus 4 over x minus 4. And then you say, oh, this one needs that x minus 2 over x minus 2, right? So you're multiplying by undercover ones there. And then what you'd realize is you can indeed cross-multiply those. And essentially what happens is that the denominators go away and you're left with just the numerators. So you end up with 1 equals a times x minus 2 plus b times x minus 4. And I'm just going to go into this space here, so I'm crossing that out. So now what we need to do is we need to kind of set up 2 mini problems where we plug in the solutions. And the idea of plugging in the solutions is that we want like either A or B to go away. Well, the only way that's going to happen is if I kind of figure out what's going on at x equals 2. And then I'm going to do another little mini problem where I figure out what's going on at x equals 4. So if I plug in x equals 2 into this line right there, then you plug in x equals 2, you're still going to have a 1 equals, but when you plug in 2 to that first part, you get 0a, right? Because 2 minus 2 is 0, so you get 0a, which is just 0, plus then you plug in 2, and you're going to get 2 minus 4 is negative 2, so you get negative 2b. Or in other words, if you wanted to solve for b, you would get b equals negative 1/2. Then you kind of do the other side. So now we're going to plug in this x equals 4, but we're again plugging it into this line there. So if you plug in 4, you still have 1 equals, you plug in 4, you get 4 minus 2 is 2, so you get 2a plus, and then if you plug in 4 to the thing next to the b, you're going to get a 0b, so just 0. And in here you'd get a equals 1/2. And I had talked about it is common for your two answers to be opposites, but it is by no means all the time. But if that happens, it's pretty common, so that's not alarming or anything. I'm just going to move myself up here. So now you've got this a and the b, and what you're going to do is you're going to take that a and b, and you're going to go back and actually plug them in. So you're going to take this, and you're plugging them in. So this is going to go in for b, this thing's going to go in for a. Okay, so you plug those in. I actually probably should have drawn those arrows up. We're actually going to plug them in up here for the A and the B. So you kind of go back to that line and you're going to plug them in. So what have we got left? Get a nice clean space. Okay, so once I go back to that line and I plug them in, okay, you are going to end up with, so that whole thing, the original equals, right? We're going to say 1/2 over x minus 4. I'm sorry, the integration of 1/2 over x minus 4 plus negative 1/2 over the x minus 2 factor dx. And then what we can do here is we can use some integral properties. So a couple things are going to happen. I'm going to take this 1/2, pop it out, and I'm also going to say that the integral of the sum is the same as the, like the integral of the whole thing is the integral of the sums. So then I'm going to take this and I can put it out there. If you wanted to factor out a 1/2 from the whole thing, you can. I'm going to wait till the next line to do that. But so I've got 1/2 the integration of 1 over x minus 4 dx, and then it'll be minus 1/2 the integration of 1 over x minus 2 dx. So now I'm ready to integrate. So after all that, you're finally ready to do your calculus step. So the calculus says that the integration of 1 over the junk, as long as the derivative of the junk is 1, then I know that the integration of that is just ln of whatever that is. And I'm also going to pull out these 1/2s. So I'm going to have 1/2, okay? And then I'm going to have, I'll do it like that. So 1/2 ln of the absolute value, right? Because we've got that. So the absolute value of this minus, okay, ln of the absolute value of x minus 2. And since we integrated, we're going to have that plus c hanging out at the end. Now, this would be a great safe step. Unfortunately, I don't picture that to be how the answer choice is written if it is on a multiple choice section. So if it was multiple choice, I would probably expect them to apply their log properties. And the log properties, when you're writing as a single logarithm, basically say this is equivalent to the ln. Subtraction changes to division. So this then becomes the absolute value of x minus 4 divided by x minus 2 plus c. And then the other thing that they may do is apply the power property of exponents, which says that this 1/2 actually becomes the power on this. So it becomes this to the 1/2 power. And then we all know that writing something to the 1/2 power is the same as taking the square root of it. So my final answer, and how I would expect to see it on the AP exam, is they would probably say that that is equivalent to ln of the absolute value, so it's power over root, so the 1/2 power becomes the square root of x minus 4 over x minus 2 and a plus c. And that would be how I'd picture the answer to be. Okay, so now I'm going to take a look at number 4. So hopefully you can see it a little better than it is on there, but it's the integration of 2x over x plus 1 times the quantity x plus 2 dx. So we are going to rewrite that as the integration. It's already factored for me, so I'm going to rewrite it as the integration of sum a over the first part plus some b value over that second factor dx. So the whole point of this is if you have the integration of junk equals the integration of some other junk, then those two pieces of junk must be equal to each other. So that's exactly what I'm going to do. I'm going to say that 2x over those two factors has to equal a over x plus 1 plus b over x plus 2. So look at this. I don't even have any more calculus on there now. It's just an Algebra 2 question. So if I gave this to an Algebra 2 student down the hall, they would tell me I need to get a common denominator. So the common denominator over here, this needs a factor of x plus 1 over x plus 1. And this one needs an x plus 2 over x plus 2. So now, since all of them have a common denominator of x plus 1, x plus 2, then you kind of ditch the denominators. And again, you can show that to yourself if you wanted to go ahead and cross multiply them. They would divide out. But you end up with 2x equals a times x plus 2 plus b times x plus 1. And now this is the part where we kind of break it up into two problems. So you kind of see what's going on first. You're plugging in, or you're kind of seeing what's going on at x equals negative 2. And if you plug in a negative 2, so negative 2 times 2 gives me a negative 4. And then from there, this piece zeroes out because negative 2 plus 2 is 0. So you could say equals 0a. And then plus negative 2 plus 1 is negative 1, so it would be a negative b. Or in other words, you could say negative 4 equals negative b, divide both sides by negative 1, and you get b equals 4. Very similarly, on the opposite side, you have to figure out what's going on at x equals negative 1. So at x equals negative 1, when you plug that in, you'd get a negative 2 equals negative a plus 0, because that second piece will 0 at that time. And then this time you are going to get, oh, wait a second, hold on. Sorry, this is a positive a. So you end up with a equals negative 2. Sorry, when I plugged in a negative 1 plus 2 gave me a positive 1, not a negative 1. Okay, so I get my a and my b, and then I'm going to take that a and b, and you're going to take those, and you'll take this one and put it right there. You'll take this a, and it's going right there. So I'm basically just going to recopy that. But when I recopy it, I'm going to say, maybe I'm going to break it up as two integrals. And maybe I'm going to factor those out in front. So you're just applying your properties. And let's see here. So I'm not working on this problem yet. Okay, so I'm still in that number 4, and I'm kind of, once I have my a and my b, I'm going to go ahead and rewrite it. So I'm saying that that original is equivalent. Now I'm going to take that negative 2, factor it out. So it would be a negative 2, the integration of 1 over x plus 1 dx. And now the other one was the b part. Well, I'm going to factor out that 4, so it becomes plus, I factor out the 4, the integration, and then I'm left with 1 over x plus 2 dx. Now I can finally do some calculus. So I've got this negative 2. The integration of 1 over the junk, as long as the derivative of the junk is 1, is just ln of the absolute value of that junk. I have this. And then plus 4 times the ln of the absolute value of x plus 2. So you've got that, and of course a plus c. Okay, so then again, this would be a perfectly valid answer. It's not incorrect, but now we would rewrite it as a single logarithm. So there's kind of a couple things that happen. This is probably going to become an exponent. The 2 becomes an exponent, and I know what you're thinking. You're thinking, hey, what about this negative? This negative means it's going to change to division. So I know some students like to kind of rewrite them so that the negative comes second, like I did, like how it was written in the first example. But hopefully after a few of these, you kind of get good. And you're like, this is going to be the ln. It's going to be the absolute value, and it'll be x plus 2 to the 4th, and then the divided by. Again, this negative here makes that divided by, and it'll be x plus 1 squared, close my absolute value, and don't forget that plus c at the end. So that would be how I would imagine the multiple choice answer to look. And that is that. Have a great day.